Okay, this video is going to serve to show you how to use the Phet simulations to understand a little bit more about forces and motion and Newton's second law, F equals ma. We're going to begin first with the Phet Colorado simulation, as you can see at the top here. You can type that into your URL browser and you just hit play. And once you hit play, you're going to have a choice of a couple different things that you can take a look at: net force, motion, friction, and acceleration. We're going to start with net force and then go to a lab with acceleration. Certainly want to encourage you to take a look at all of these and get an idea of more about the effect of friction and so on how an object moves. But on this one, on the net force, very, very simple. Each one of these people can be dragged up to the top. The smaller people are representing a force of 50 newtons, right? And you can choose these values here. And of course, the larger person would be even more, right? So each person representing different amounts of forces, right? So as I take people on and off, that'll give me a different amount of force. And I can place these people up here. And as you can see, the amount of force going one way might be different than another. And when you hit go, it's just going to have the effect of the object moving in the direction of the greater net force. So what you also can hit here is the sum of the forces. Of course, if you have 100 to the right, 250 to the left, you're going to be left with 150 to the left. So while you're working on that, just some scenarios that I would like you to fill in and take a look at each of these scenarios. What would happen if I had the same size people at the same place and on the rope? What do you predict is going to happen? What actually happened? And what is the sum of the forces? So tell me, is it to the left or to the right or zero, and how much it is? So in that first simulation, just to play around all these different tasks, take a look at each one of those, and you can complete the questions going along with those scenarios. Okay, so that's pretty basic on the Phet simulation. If you go back and we go to the acceleration one, so if I want to choose instead, I would like you to take a look at acceleration. So we're going to take a look at this one. Is a little bit more complicated. And I do like to see the values, so we can see the values of all the masses as we take a look at everything. So what are all the masses? What is the acceleration? So you can see, we can click on this. We can also see the sum of the forces, all of those kinds of things. So what you're going to do in this case is you're going to follow this sheet and complete your data sheet based on each one of these scenarios. Okay, we're going to try to set up each one of these and see if your calculations are correct. You don't even need the simulation to fill this up. You're going to fill in your force diagram, okay, by showing me what forces are present on the object. Okay, so we're going to go in and let's see. Okay, I changed to take away the force diagram drawings there, and we're going to add to that as we go through. So what you can do is bounce back and forth from the simulation and from your drawing. So if we go to the simulation, we have the object. We want to make it so the mass is 130 kilograms. So to make it 130, if the box already is 50, we're going to add this gentleman who is 80, so that together the whole thing is 130. So if I look at the box as it is right now, and I go back and I want to fill in my force diagram, right? What we would show here is that here is my box, right? And what forces would be present? There would be weight acting straight down on the box, and there would be a normal force acting straight up. Those two are equal to each other, so we're going to eliminate them and say they cancel one another out. If then, when I go back to the simulation and I apply a force of 100 newtons with a frictional force in the opposite direction of 30, so here's my applied force, and I just choose, as I hit this, it'll give me different values of the applied force, right? If I want it to be at 100, right, exactly 100, I think you can just dial that up, 50, 100 newtons, there we go. And then our frictional force, so this is my applied force is shown on the right, frictional force on the left. We're going to dial that back and try to get it to be about 30. So this is where it's a little bit challenging because it's hard to get it exactly at the value that you want, because I'm not able to just dial that up. So getting it right at 30 is a little bit of a challenge there. So right now, as shown, my net force would be 71, and we have motion taking place, my acceleration of 0.55. So I'm going to go back to my diagram here, and what I have, as I write this in, I would then show I have an applied force in this direction that is more than my frictional force in the opposite direction. My net force is going to be my force applied minus my force of friction, right? Because they're in opposite directions. So my net force is equal to the 100 newtons minus the 30 newtons, or my net force is equal to 70 newtons. So my calculations, my calculated accelerated force would be 70 newtons divided by 130 kilograms. So what do I get when I take 70 newtons divided by 130 kilograms? Plug that into your calculator. And I get 0.54 meters per second squared. So if I go back to my simulation, I can just use the simulation to say, am I close? So remember, I didn't quite get 30. This is at 29. So 0.55 is my acceleration, which is what I just calculated. So really, you are using the simulation just to test out to see if your calculations are correct on this sheet. So hopefully that helps you. And as you complete the sheet, there's a few questions at the end. So each scenario causes you to do something different in the simulation here. So whether it is that you add more people, right? So if I want to reset it, I just hit this button off to the right and it resets everything back. So I'm going to pause it. And then we're going to reset everything back. And then I can start all over again. Okay. So have some fun with that. And you will be turning in that worksheet to show me that you understand a little bit more about Newton's second law.